Let's go through the code 1630. Arithmetic subarrays. For this question, it gives us an integer array nums, and also it gives us L integer array, right integer array. So it says that we are trying to query from the left index to right index, and trying to see, for example, 0 to 2, right? 4, 6, 5, and trying to see whether this kind of subarray will be arithmetic sequence. So we can reorder it. For example, change the order to be 4, 5, 6. That is, so it will return true because 4, 5, 6 is the arithmetic sequence. So the definition of arithmetic sequence is that we have si plus 1 minus si equals s1 minus s0. And so it lets us to return a list of Boolean for all of the queries. So it says that the L length and R length, they are equal to M. So there are M queries. And the number N, numbers length is N, right? So I have N equals numbers length. And M equals alphabet length. So we know the result list Boolean will have m element for m queries. So in for these questions, what we're thinking about is that we for every query. So for int I put 0. I smaller than m by I plus plus, trying to see whether the integer from the numbers from the will have the s index, start index equals to left, right? Left I, and the end index equals to right. And we're trying to check the numbers from this s index to end index, whether they are arithmetic subsequence, right? So we can use a list to add the values to it and then sort. Then there are so for this kind of operation, sort it will be, if we sort, right? Sort, that will be O of the operation. List Boolean result was new array is correct. So it's just the result add is arithmetic some nums s index and index, right? And then in the end, we just return result. So intuitively, what we do this is arithmetic. We just use a array list to add those values to it, right? Array is arithmetic. In nums as index int and index. So we just have, for example, list make it we have list because new array list for I equals s index I smaller equal to and index I plus plus and what we are going to do is that we just list add nums and after that we have collection for list and for int I equals 1 okay that's smaller than this but size I plus plus equal um so we can do this right if list the dot size it's int size equals list dot size if size is smaller than 2 size is smaller equal to 2 we return 2 okay you can write equal and index minus s index smaller than 2 right then return 2 in that case the size will always be greater or equal to 3 right so we'll have from 2 okay I have intercept for the list greater 1 minus list greater 0 right and from 2 if list greater I minus list greater I minus 1 doesn't equal to gap or the false otherwise we return true right so and index doing like this way this kind of operation will be O A log n and also space will be O(n). So actually we can do this better, right? We can use a set. Actually we can use a set. So how can we see whether not these numbers here are arithmetic subsequence? What we are going to do is that we can use that because hash that okay and we'll have set address right and what we need is we are going to have a minimal value as an integer that means from this s index to the n index we have a max value and max equals integer min value okay. So we'll have min because next dot min num side and max equals max dot max nums r. And in this case, we are not going to, we don't need to solve, right? So we know the gap. The gap will be doing like this, will be max minus min divided by n index minus s index. We'll write equal max minus min. Because this one mod, it's not cannot mod this one, right? And the index s index. This one doesn't equal to yeah, it's just return false. Error this condition, right? Otherwise, we're going to have this gap. And now we are going to do like this. Yeah. We have size. But this one size equals and the index minus s index. Okay. So if the size smaller than 2, so what we are going to do is that int value equals min. For int I equals 0, I smaller than size. And let's say equal set value contains value return false, right? That's and we'll have value equal that's equal to gap. Okay. Of course, we can write a smaller equal, right? So that the math will be included. One of the tricky things is that we cannot write something like this for int value equal to min, value smaller equal to max, value plus equal to gap, right? Because it is possible the minimal and the value maximal will be 0. They are equal, right? So the gap will be 0. In that case, this will be infinity loop. I will have timeout error. So this one, the corner case gap equals to 0 or timeout. So, but we can write this, right? Because we just have the size run our iterations. Doing like this time complexity will be O n. And so the total complexity will be O n multiplied by n, right? Base will be also n multiplied by n, right? Because we have this kind of actually this also this will be ON, right? We just create this will be ON space, right? But This depends on how we define. We have also create m times. But this will be we doing like this. This will be linear time complexity. Let me see. Set 22. This will be set.